Hi student, in this lecture we are learning the antenna parameters. In this first lecture we learn radiation pattern. Second parameter is beam area and beam efficiency. Third parameter is directivity and next parameter is antenna. This parameter we learned in the last lecture. In today's lecture we are going to study the remaining parameters of the antenna, which are radiation intensity, antenna impedance, radiation efficiency, bandwidth, and polarization. So these parameters are important at the time of the selection of the antenna for specific applications. So first parameter in the second lecture is radiation intensity. So what is the mean by the radiation intensity? So it is given radiation intensity in a given direction is defined as the power radiated from an antenna per unit solid angle. Now, the name suggests that the radiation intensity is nothing but the how the energy is concentrated in a particular region or the particular area. And to learn or to understand this radiation concept, I have taken here one concept that is shown here, magnet, and it radiate it magnetic flux. There are the three regions I have drawn. First name is low, second is the high, and third one is the medium. So these are the nothing but the magnetic lines generated from the north pole, and these are again meeting to the south pole, something like this, or something like this. So if you take the unit area at this point, so only one line is cutting this area. So because of the only one line is cutting, so we say that this density of the magnetic flux is very low. In the second, if you take the same area and if you look, there are the so many lines cutting the this area, so I said that it is high. And in the second, the magnetic lines cutting that area are the two lines. So here one line, here is more than the five lines, and here are the two lines, and I name here low, high, and medium. In the same way, if you take the antenna, and if antenna is radiated in a specific directions for the long distance, and if you measure that radiations of the antenna in that particular distance with some solid angle, and if you get the more density of that magnetic flux, then we can be say that this radiation intensity is high. So mathematically the radiation intensity is expressed in the unit, or the mathematical expression is U is equal to R square multiply the W radians, where U is the radiation intensity, how much is the radiation intensity of the antenna, and second is the W. So W is nothing but the radiation density. So density is nothing but the like this. There is a low density. This is a medium density, two lines, and there is a high density because there is a more than the five or six lines. So same way. And R is nothing but the distance. At what distance these lines are still present. Density is still present. As the distance increases and still it maintains that radiation intensity, that radiation density, that means this antenna is more intensity antenna. Now next parameter of the antenna, that is nothing but the input resistance or the antenna impedance. So resistance or impedance is simply, we can be defined as it is a simple ratio of the voltage to the current. So it is defined as the impedance presented by antenna at its terminal. Terminus is nothing but the at the A and B. This is the terminal of the antenna. Is the ratio of the voltage at this point, voltage and current flowing from the that antenna, and it is mathematically expressed as the antenna impedance is denoted by the capital ZA is equal to RA plus JXA. So antenna impedance is nothing but the combination of the real part RA, and second one is the imaginary part, that is nothing but the JXA. So this imaginary part is created because of the some lump element. If you take the straight wire, it can be in that straight wire there may be present a number of the inductor, and if you take the such type of the wires, there must be a number of the inductors present in the wire and series inductor, and there may be some parallel capacitors are present, and because of this inductor and capacitor there is some resistance created, and this resistance is represented as a complex impedance. And first one is a real resistance. So this real resistance or resistive part is represented here. Ra is equal to Rr plus Ra, where Rr is nothing but the radiation resistance of the antenna, and second one is nothing but the Ra. So Ra is nothing but the loss resistance of the antenna. So first part RL is the radiation resistance of the antenna. When antenna, so this is the antenna, and when it is radiated, it's electromagnetic energy. So this space, vacuum or whatever may be this free space, it opposes that radiation. So that opposition is represented by the R, and RL is nothing but the loss resistance of the antenna. So when you feed the energy from the generator to the antenna, so from this feed point to the this antenna up to the radiation, so some energy is lost in the form of the heat or other components. So that energy or this loss is nothing but the loss resistance of the antenna. So here I have shown in the pictorial form of the rail part, that is the resistive part, RA plus RA. So if you provide some energy generated to the antenna, so this is the antenna structure, and you provide some energy. So if you provide 100% energy to the antenna, out of 100% of that energy, 25% energy is lost into the this antenna as a resistive loss. This is a resistive loss. This is loss resistance of the antenna. So this is a 25%, and 75% is nothing but the radiation resistance of the antenna. So this is a 75%. Okay. So next parameter of antenna is the polarization. So what I mean by the polarization, and to understand the polarization, first learn the basic concept of the electromagnetic waves. If you take the electromagnetic field, and this electromagnetic field is nothing but the electric and magnetic component. That means electromagnetic waves consist of the electric and magnetic field component, and this electric and magnetic field component are perpendicular to each other, and they are both propagating to the direction of the propagation. So this figure shows the electromagnetic waves or the radio waves, and it consists of the two components. One is a electric component, that is shown is a red color electric component, and second one is a magnetic field or magnetic component, and its polarization is denoted by the electric field. So here the direction of the oscillation of the electric field component is represent the polarization of the waves, and this polarization component is important at the time of the antenna transmission or the receiving. If you transmit the electromagnetic waves from one point to the next point, or the at the other point, so at the other point there is a second antenna that work as a receiving function, and at the time of the transmission side, if you use vertical polarization, and at the time of the receiving, if you use antenna with a horizontal polarization. So in this condition, the transmission is not performed the better way, because for the proper transmission of the signal from the transmitter to the receiver, the both antenna That means transmitting antenna and the receiving antenna both have the same polarization, vertical to vertical. That means transmitting antenna must have vertical and receiving antenna must have the vertical. If the transmitting antenna transmitting the electromagnetic waves with the horizontal polarized, so that time the receiving antenna should have the polarization of the horizontal. So this is a concept of the polarization. So depend on the electric field. So there are the three types of the polarization. One is a linear polarization. So again I'm saying what do you mean by the polarization? The electric nature of the wave is represented by the polarization. If the electric field is a vertical nature, that means this wave, this electromagnetic signals is a vertical polarization. And instead of this magnetic field, so if the blue line is the electric fields and red line is the magnetic fields, that time we says that this wave is a horizontal polarized. And depends on the electric fields. There are the three types of the polarization. One is the linear polarization, second one is a circular polarization, and third one is the elliptical polarization. So in this slide we learning the linear polarization. So linear polarization again have the two types. One is the horizontal polarization and second one is vertical polarization. So what do you mean by the horizontal polarization? So in horizontal polarization, the electric field is nothing but the up, sorry, towards the plane and downside to the plane of the z-axis. This side and back side, that is front side and back side. This is front side, back side of the z-axis. This is horizontal polarization. And in case of the vertical polarization, the electric fields flow in the upside and downside, upside and downside. So this is a vertical polarization, up and down. So depends on the electric fields. There are the two types, horizontal and the vertical. Next type is a circular polarization. So in this circular polarization, the magnitude of the electric field is a constant, but its angle it changes in the circular way. It follows the circular nature. It intensity it does not change. Magnitude it does not change. Only the direction of the transmission it changes in the circular nature. In the circular nature. So it follows the circular nature. Its intensity or its magnitude does not change. Magnitude is fixed. Look at any point the magnitude is the same. This magnitude is same, this magnitude is same, this magnitude again same. At any point magnitude is same. Only there is direction it changes. And in second type elliptical polarization, the electric fields follow the elliptical nature. That means its magnitude also changes in the elliptical nature. Some point at this point the magnitude is small. At point this magnitude of the electric field is high and it follow the elliptical nature. So this is the third type of the polarization. Now next parameter of an antenna is the bandwidth. And bandwidth is simply we can be defined as it is a difference between the upper cutoff and the lower cutoff. So this is simple definition we can be say for the bandwidth. But for the antenna we define the bandwidth as the range of frequency within which the performance of an antenna with respect to some characteristics conforms to a specific standards. That means we learn various parameters or some characteristics of an antenna. These characteristics nothing but the gain of the antenna, directivity of the antenna, radiation pattern of the antenna, its beam width. So these parameters we get the good performance, antenna resistance, impedance. So we get the some specific standards for these frequencies. That means within that frequency range, the antenna gives the good performance or maximum performance. So that is nothing but the bandwidth of the antenna. So if you take the example, half-wave dipole antenna transmit in the frequency range of 380 megahertz to the 470 megahertz. That means in this region, this half dipole antenna is give the good performance corresponding to the gain, directivity, impedance, radiation patterns, and from that we can calculate the bandwidth of an antenna is nothing but the 90 megahertz. So within the 90 megahertz frequency range, so this antenna can transmit better with or the within the 90 megahertz frequency range, this antenna can receive the good or give the good performance. So next important parameter of an antenna is radiation efficiency or the antenna efficiency, and it simply tells that the how much power it transmit into the space where we fed some power. That means if you provide P in input power and if it radiate P power into the space, and that ratio is nothing but the simply efficiency. That means how much it able to transmit into the space and how much energy is wasted into the antenna. So efficiency of an antenna is strongly depends on the its wastage of the energy of an antenna. That means if you say the antenna is high efficient, the meaning is that this antenna radiate more power into the space and wastage less power into the itself as a resistive loss or something. And when you are saying the antenna is a low efficient, that means it wasting the more power into itself as a resistive loss or something losses and radiating the less power into the space. And depends on the efficiency, the scientist or the researcher is trying to develop high efficiency antenna. That means it able to transmit a more energy into the space and wastage less energy into the itself. And antenna efficiency is always in the range of the 0 to 1. So for this lecture, I use these references. Thank you.